Hello grade 11s, welcome to my channel, and let us have a look into this question paper which was from KZN June 2024. Okay, just going to discuss questions that are of relevance to your upcoming exam for the mid-year examinations. Alright, so we've done some work already in the channel. Please make sure you get abreast with all of it. Do not skim and scan. Please get through all the work that we've done. You will see how well you will do in your exams, starting from now going forward. Anyway, we start with our instructions. And of course, guys, we read instructions with understanding and ensuring that we stick by them unless something else is stated locally. All right. So obviously, this instruction, folks, you want to always look for it as well as that to ensure that this part is clear. So again here, strictly 2 decimal places, no more, no less. All right. And if we do any calculations, we need to show everything, including the diagrams we may have used or graphs, and absolutely anything that is applicable. So let's just get to the algebraic section, which is the bread and butter of mathematics of higher order nature, isn't it? Yes. So we're doing question 1. Again, we're going to be handling quadratics of different forms usually, and some extra algebraic expressions that are of importance at this level. So we've got 1.1 with 1.1.1. So we've got x into 1 minus 2x is equal to 0. Now, following our 3-step approach, we know that once we have a product that is equal to 0, it is as good as suggesting that the first factor must be equal to 0 or the second factor. Essentially, I don't like to waste time. All I just simply do, I take this, equate to 0, and what? Transpose x becomes positive divided by 2. So x is going to be a half. Great. So, of course, at this level, you may want to show the first step of splitting these two into 2 different factors that are equal to 0 and then solve further. But essentially, that is clear. So let's check. We take this x and place it where x is. So this becomes 0. 0 multiplied by anything is going to be 0. So this checks out. If we put x as a half, that would be a half over there. But if we put a half in here, it becomes 1. 1 minus 1 is 0. 0 multiplied by anything is 0. So the left-hand side is equal to the right-hand side. And only then do we move forward, once we are sure no marks are being lost. Because it's easy to think that all went well. You see, easy questions, there's a lapse of concentration by a student, and usually a mess up of a sign or even a number, which happens sometimes. I don't know why, but it does. Then we run into serious problems. With this one, we can attempt to factorize. Usually we win, sometimes we don't. And again, if you are not so sure what to do, please check the discriminant. All right, check the status of the discriminant. If it is a perfect square, it means this can be factorized. If not, then we use the quadratic formula or completing the square. Okay, this is going to be minus. Okay, now we need to be strategic here. This is going to be minus 1, minus 3, right? Right. So therefore, x should be 3 over 2, or x should be 1. All right. Now we look again and see, if we put 3 over 2 there, what do we get? Well, this is going to be squared, so this essentially becomes 9 over 4. Okay, then 2 goes, and then we remain with 2, so this becomes 9 over 2. And then here we're going to get essentially 15 over 2, and we have 3 there. So let's see, 9 over 2 minus 15 over 2 should be minus 3, right? 9 over 2 minus 15 over 2. Yeah, I think so. 9 minus 15 is basically 6. Minus 6. And that gives us minus 3. So minus 3 plus 3, that's 0. And that's good. The solution holds. When we put a 1 in there, we get 2 minus 5, that's minus 3. Minus 3 plus 3 is 0. So the left-hand side is equal to the right-hand side. Get into the habit of checking answers before moving on. It helps to do so because even a mistake is quickly uncovered before it's too late. All right, we've got x into 3x minus 5 is equal to 7. Now this should be already very clear. Once we have that statement provided alongside an equation, we know that the roots are irrational. But remember, it may not be stated at all. A student needs to know when to use the quadratic formula on their own. They don't need to be prompted by this. This is just a friendly reminder, I guess, which is unnecessary in all honesty. Anyway, folks, we know that we have to first follow our order of operations. We deal with these brackets. So this is going to be 3x squared minus 5x. We transpose the 7. And we have our business in order. Right. So with that indication, we don't even bother checking the discriminant. But when we didn't know, we would probably have to, before we start sweating with trying to find factors. That would be a fruitless exercise. Okay. Go on. Okay, we need to write the quadratic formula first, and we then substitute. Minus into minus 5 plus or minus minus 5 minus 4 into 3 into minus 7, all divided by 2 into 3. At this stage, guys, I do not believe in wasting time simplifying what is not going to be rational, because at the end of the day, this remains as is. So we will never get rid of that square root technically. So we just go with the flow. We go with the flow. So this is minus into minus 5 plus the square root of minus 5 squared minus 4 into 3 into minus 7, all divided by 2 into 3. So I'm getting 2.57 to 2 decimal places, or x is, nice thing is that the calculators of today are a lot better. There's no repeating the entire process. So this is minus 0.91 to 2 decimal places. And we close shop. All right. Remember, folks, let's not be too excited. We got solutions. We need to check them in the original expression. Okay. Great. Now we go back and say, okay, we've got x there, which is 2, 57, okay, into 3 into 2 comma 57. Please know how to use brackets effectively, or else there will be problems. So now see, the right hand side is effectively a whole number, so this means we will round off the left to the nearest whole number, and when we do from the answer I get, it is as good as 7, so I can accept this solution. Now let's go back and change things again. Now we put for x minus 0, minus 0 comma 91 minus 0 comma 91. Okay, this one gives me 7 nicely. Okay, of course there's still some few decimals which are insignificant. Now obviously folks, the extra mark here is substitutions and writing this in standard format. Okay, so that's just a plan that should do the magics. In fact, I did not mark this one properly, so this one was 3 marks. Okay, great, we're doing great. So let's do 1.1.4. We've got inequalities there. 1 minus x into x plus 3 is less than or equal to minus 5. Now, with this product, we're not going to take chances. If this is not 0, we're not going to equate this to 5, minus 5, and that. So we need to deal with this following our order of operations. Foiling this out, what do we get? Minus x squared here, and we're going to have we're going to get x minus 3x is going to be minus 2x, and we've got plus 3. We bring in the 5, becomes plus 5, less than or equal to 0. So this implies that we've got minus x squared minus 2x plus 8 is less than or equal to 0. So what I would like to do is to just factorize my business here. Most likely it will work. If it doesn't, we abandon the thought. Alright, so what do we have now? Factors of 8 that can give us a 2 is a 4 and a 2. But now we need the 4 to carry the sign of the middle term. But nicely these ones fit into. Okay, I think a big mistake here. This should be plus and that should be plus. Yeah. We'll have that negative. So this becomes minus 4x plus 2x. It gives us what we get. So, of course, folks, right here, we go straight to the graphical method. It solves our pain much easily. It makes our lives a lot easier. But remember, anything that you are comfortable with as a student, use it. So our graph is a grumpy face parabola with this as this is going to be minus 4 and 2. So this is the stuff that we will get. Right. So this becomes minus 4. Actually, I should have made it a little bit different because my axis of symmetry is on that side. So my graph, this is supposed to be stuff like this. So I like near perfect sketches because it catches someone out when it gets to some serious higher grade questions, which no one can escape, right? No one can escape the higher grade questions. They always keep coming, and we have to deal with it. All right. So that's it. Our axis of symmetry is to the left of the y-axis. So I like to make sure my sketch represents what I need. Now I want this to be less than 0. Now the graph is less than 0 here. These x values give us they give us y values that are less than 0, right? As well as these x values are giving us y values that are less than 0. All right, so those are the areas of our solutions. So we will write here, therefore our x must be less than, by the way, 0 is included, or equal to -4, or x must be greater than or equal to 2. Of course, sometimes it is nice to write this, but not writing it is good, because here the domain is the element of real numbers. So writing it and not writing it is really not that important. But if you just make this a ritual of some sort, when it is necessary, you will not fall off. So try to do things that protect you automatically, rather than to go blindly and then always find out the hard way. All right, so what is most important here is to get this inequality, to factorize it, and to get our solutions. So that's the 4 marks, nice and easy. But remember, we need to show how we got to those solutions. We don't just write them. Right. Nice. So we've got 1.1.5. We've got x squared plus 7, all divided by x squared minus 2x minus 3 plus 2 divided by x plus 1 is equal to -1, all divided by, oops, too much, all divided by x minus 3. Now, you know, rational fractions, or should we say rational equations, are interesting, but it's nothing but a parabola, because we can see that we've got a parabola right here. And the first thing that we need to do is to just factorize this thing. This one is not necessarily factorizable, so we leave it as it is. Divide this by, when we factorize here, we're going to get x minus 3 into x plus 1. In fact, the examiners already gave us a clue with these factors right here. So a student who's well aware would see that these are actually factors to this parabola. So this is plus 2 over x plus 1 equals minus 1 over x minus 3. Now, folks, what do? We then need to multiply by the common denominator, which is going to be x minus 3 into x plus 1, because this is common. So this can go in there, this can go in there, it can go into itself. All right, so this is the concept of common denominator. Avoid that word LCD. It's ridiculous. Doesn't make any sense after all. So when we do this, we get x squared plus 7 plus 2 into x minus 3 is equal to minus into x plus 1. Okay, so again, this is something a student who's doing grade 11 should know, instead of needing to write this first and then see the cancellations, or should I say the divisions, because there's no cancellations per se, but there's divisions that take place. Since 1 becomes a multiplicative identity, so it doesn't change the result, so we kind of negate it, or neglect it, or abandon it. Right, this is x squared plus 7 plus 2x minus 6 equals minus x minus 1. This implies that we've got x squared. We bring in this x, gonna get plus 3x. Then we bring in the minus 1 here. By the way, 7 minus 6 is 1. 1 plus 1 is going to be 2, equal to 0. You're too far. Hadamela. Go shebele haufinyana mona. Now guys, can we factorize this thing? Definitely we can. If you're not sure, check the discriminant. So this is x plus 2 plus 1. Therefore, x must be minus 1, or x must be minus 2. Now, are these perfect? No. And again, with rational equations, rational in the sense that we've got divisions or fractions, the denominators must never be 0. So if you don't check, you will always get one answer right and lose the other. So we need to check when we substitute this where x is, we must make sure the denominators are not 0. For example, if you look at this one already, right here, minus 1 there gives us minus 1 plus 1, which becomes 0. A denominator that is 0 is undefined, so we can immediately reject this solution without wasting our time checking it elsewhere. But minus 2 should be the one, because minus 2 squared, that's 4, plus 4, that becomes 8. 8 minus 3, that's 5. You see, it's a good number. Minus 2 plus 1 is minus 1. Minus 2 minus 3 is minus 5. Can you see the denominators hold? Now the question is the left-hand side equal to the right-hand side? Well, we can check it out using our calculators. So we go on and say, okay, fine, minus 2 squared, it's off. We can say here minus 2 squared plus 7 divided by minus 2 squared minus 2 into minus 2 minus 3 plus 2 divided by minus 2 plus 1. Now let's see if, so we get 1/5, right? Now let's put minus 2 there. We definitely get 1/5. So the left hand side is equal to the right hand side. But we'll get marks either way. 1 is correct, 1 is not correct. Okay, so 5 marks here. So I guess multiplying by the common denominator is key. And factorizing, remember, whenever we factorize, that is key. And if we got a mark for factorizations, I suppose just writing this quadratic in standard format is good. We cannot get a mark for factorizations twice in the same question. But it can be considered because, again, it is at the discretion of the examiners. Great stuff. So we move on. So we've got 1.2, where we are given x minus 3 is equal to 2 root, it's too long, 2 root x. Okay, now we're told to solve for x. Easy. Radicals 1.2.1. We've got x minus 3 is equal to 2 root x. Now this implies that we've got x minus 3 all squared equals 2 root x all squared. So what we do on the one hand side, we must do on the other hand side. This becomes x squared minus 6x plus 9 equals 4x. Right. Now we write our quadratic in standard format. X squared minus 10x plus 9 equals 0. We can factorize successfully. So that's x minus 9 minus 1. Therefore, x is 1 or x is 9. Again, with radicals, we need to be sure that we don't have a negative under the square root. Good. Now we check that the left hand side is equal to the right hand side. When x is 1, this is minus 2. But when x is 1 here, what do we get? 2. So minus 2 is not equal to 2. So we reject this solution. The left hand side is not equal to the right hand side. 9, we get 9 minus 3, that's 6. Here, square root of 9 is 3. 3 times 2, that's 6. So the left hand side is equal to the right hand side. That's good. We get a mark for the gymnastic. Whenever we factorize, we get a mark. For the rejection, we get a mark. How many marks is this? 4. This is good enough. So 1.2. It says, hence, if this is the case, determine the value of t. Okay, let's write it. We've got the cube root of 3t minus 2 times the square root of the cube root. Okay, let's do it better. 2 times the square root of the cube root of 3t equals 3. So now this is one of those higher grade questions, but this statement hence is already indicating that we will have to draw from 1.2.3. Sorry, 0.1. I don't know why I'm thinking of 1.2.3. Now remember, folks, we had x minus 3. Now we can let the square root, the cube root, because you can see this dude is still under the square root as well. So we can make that dude x. We can say let the cube root of 3t be equal to x. This implies that we've got x minus 2 root x equals 3. Then we arrange it so that it looks exactly like it was above. Then we end up with x minus 3 is equal to 2 root x. Can you see? Now we know this is the equation, and we're not going to do all the gymnastics. We just skip to the answer. We say this implies that what am I going to say? We need to solve here. So there's only one solution, right? It's that one. So we know that this implies that x is equal to 9 because we cannot have 1. So this also implies that the cube root of 3t is 9. Now folks, what are we supposed to do? we convert this to exponential form. So this implies that 3t all to the 1 over 3 is 3 squared. Okay, all right, okay. So what do we need? Well, this question is crazy now. Why is it long? I don't like long questions. Okay, let's split this portion of our solutions and write them also on this side. Great. So what we're going to do there, we simply are going to multiply by a third. I think that's what we need to do, but I think we need to just first distribute that. So it's going to be 3 to the third times t to the third. Right? Right. In fact, we can change this to the root form. It's not a big deal. We see that we've got 3 squared. We divide by this. We know that this implies that the cube root of t, I think it's best to go back, is equal to. Now, when we divide by this, then we take it up, it becomes 3 to the, now 2 minus a third, this is 6 minus 1, which is 5 over 3. So this is going to be 3 to the 5 over 3. Crazy question there. 3 to the 5 over 3. Okay, so I'm using exponential laws. So when we divide by this here, we'll then move the base to the numerator and the exponents will subtract. So 2 minus a third is 5 over 3. Okay, great. So what are we going to do now? We then cube each side. And what we do there, we do to the other side. So this implies that t is going to be 3 and 3 will take each other off. It becomes 3 to the 5. Therefore t is, that's 81 times 3, ne? Which becomes 243. Answer. Okay, so that was a lot of work for just 3 marks. But again, it's only because we're using substitution method. And if you think about it, it's nothing but simultaneous equations of some sort here. But which is a strange type. You don't really see it coming. Okay. Now, what is going on? Where do we get the marks? I believe making this conclusion is key. And the answer. So where do we get the other mark? Okay guys, the rest of the marks are truly debatable because there's lots of laws. We've used laws of exponents here. We've also used laws of exponents there. And the gymnastic on top of it. So for me, I would say perhaps this one has 2 things happening. We can take it as the extra mark. Either way, we will see what the marking guidelines say, which at this point we don't care because if we get our answer right, that's what we want to see. Now folks, don't get too excited. Go back. Go back. A mistake could have happened. So we go shift, square root, so that becomes a cube root of 3 into 243, right? Minus 2 into shift, oops. Okay, let's first take the square root. Minus 2 into the square root of a cube root of 3 into 243. Please know how to write these things even with the calculator, guys. There is no excuse here. So let's see if that is equal to 3. Indeed, I'm getting 3 is equal to 3. So this means it's a valid solution for t. So that's good. We stop there. All right. Okay. All right. Please, if one is going to write this way and right here, please draw a line that separates the two sides. Because if you don't draw the line, someone is going to think from this step you went here, and that doesn't make sense, and then there, and then there. So a lot of controversy can be created by that. Although someone who wants to care for you would know that the steps are going all this way and then to the other side. But this is the method of ensuring that even a strict marker doesn't have a leg to stand on, okay? Destroy those legs. Destroy those legs. Anyway, we go to the normal standard simultaneous equations. So we've got 3y equals x plus 1. And this implies that we have x is equal to 3y minus 1. We can make equation 1, and this one, x minus y into 5y minus 3x is equal to 0. We make that equation 2, so we just say put 1 into 2. What do we see? Where we see x, we put 3y minus 1 minus y into 5y minus into 3y, so we need a square bracket here. Okay, please guys, the notations must be right. Minus 3y minus 1. Actually, there's a 3 here, so we need to move stuff again. So pay attention, don't be like me. Everything must be proper. Okay, so is equal to 0. All right, so we follow our bottomers now. So this is going to be 3y minus y. It's going to be 2y minus 1. Okay, so to kill the square bracket, we break that. So it's going to be 5y minus 9y plus 3 is equal to 0. So once you break this, we do not want to see a square bracket here. If you maintain the square bracket, you are lost. Okay, it doesn't hurt though, but methodically it causes problems. Okay, so always know what is what and what is its function and how to handle it. So we continue here. So we've got 2y minus 1 into, this is going to be basically 3 minus 4y equal to 0. These are factors, so it's already factorized for us. You see, not expanding it helped us out to avoid factorizations. It means now y is a half, or y is going to be equal to 3 over 4. Right. Therefore, x is going to be equal to 3 into a half minus 1, or x is going to be equal to 3 into 3 over 4. Oops. Minus 1. Now, this is 3 over 2. 2 times 1, that's 2. 3 minus 2, that's 1 over 2. So that's a half. One can think of it as 3 halves minus 1 half. So what, 3 halves minus 2 halves, because 1 is 2 halves. So that's just 1 half. Okay. And then we come here, so this is 9 over 4. Again, 4 times 1 is minus 4. 9 minus 4 is 5 over 4. So it's 5 quarters. Again, one can think of this as basically, how could we look at it? Yikes. If we factor out this 3, we will have 9. Think of it as 9 quarters minus 4 quarters. We will have 5 quarters. Okay. So again, look at the expressions, guys, even without a calculator, and be able to make a conclusion. Of course, don't fry your brain too much. You still need it for the rest of the exam. So there are some areas where it will be clearly stated, no use of a calculator. All right, let's check if everything balances out. So we take a half and a half. Wow. If this is a half, let's see. 3 halves minus 2 halves, it's a half. So this means left hand side equals the right hand side. But again, this is the manipulated version. So let's not check it there. That's a crime. We check it into the original, provided we copied it correctly. So this is 3 halves. This one is going to be a half plus 1. So this is 2 plus 1, that's 3 over 2. So again, we're going to have 3 halves, 3 halves. So the left hand side is equal to the right hand side, okay? I'm lazy to check this one, but I would assume it's good. And of course, putting one into the other usually gives us the extra mark. But sometimes it's not so strong. Actually, making this equation 1, sorting it up, is actually key. But again, in this case, you can see these two are equally important. So you choose any one of the two for the extra mark. Not a big deal. So we have 1.4. 1.4, we are told that the roots of the equation x squared minus x minus 3x minus k are equal to 0. And now these are the roots. All right. Now we need to determine the value of k. So what do we think, guys? Well, we don't care about the rest of this stuff, right? We really don't. But if one notices is that there's a 3 here and there's another 3 here. So inspection, inspection, inspection. This one is good because 2 times 1, which is already 1, is good. We don't worry about that. At the same time, we knew that this was minus 3, so this should be b. So this 3 root 5 is a simplification of the discriminant under the square root. And so we are going to say, we understand that essentially b squared minus 4ac should give us 3 root 5. That's what we know. So this is a very nice question because it begs the question that, do you understand how to look at what you are given, and can you make a decision? Remember, this discriminant under, in fact, we can even write that the square root of the discriminant simplified to, yes, this is the correct way. We knew that the square root of the discriminant simplified to this. We don't care about the signs. It's not a big deal at this stage. So we move on. Say this implies, we then substitute into the discriminant. B is minus 3 squared minus 4 into 1 into minus k. This is equal to 3 root 5. Okay. Now there's two ways of doing this. Obviously, one would want to square both sides and solve, or just take the 3 inside. Once we take the 3 inside, we literally equate that expression to what is inside. But remember, 3, when it goes back inside, it has to be 3 squared. Okay? So, again, it depends on how you started as a student, so we don't really care. We would still get exactly what we would get anyway. So we move on and say, okay, we understand that this is 9 minus 4 plus 4k. This is 9 times 5, which is 45, which would have been the case anyway when we took the 3 and put it inside. And nice enough, we would still end up with this logically. So we just simply continue. So 4k is going to be 9 minus 4, that's 5. We bring into the other side, we get 40. So therefore, k is what? 10 is 10, 10, 10, 10, 10, 10. Okay, so that's good. We are happy now. Everything is good, if not gooder, if not goodest. Anyhow, one can check if indeed, when we say k is 10, do we get 3 root 5 on the discriminant? That's how we can check this. So let's say, well, we knew that in the quadratic we would have minus 3 squared minus 4 into 1 into minus k. Now remember, k is 10, so this is going to be minus 10. Right. And then I'm trying to think now, is there a crime? But let's check. This is going to be the square root of 9 minus 4 plus 40. Now this is 5, this is the square root of 45. It goes back indeed. Square root of 45. Now we need to check. This is 9 times 5. So this is the same as 9 times 5. And then perfect square 9 is going to be 3 root 5. I think we are good. We are very good indeed. Remember, k here is in isolation. We don't really care about the sign before it. If we were to write the equation, it would be x squared minus 3x minus 10. Okay, so that's a nice question. So we have done our job. So literally, guys, this is indeed a mark, knowing that we needed this. And essentially substitutions, very important. And perhaps the gymnastic as well. This is too easy. The answer is probably what matters. All right, so that's not a very difficult question after all, but it picks your brain a bit. And of course, a student who responds very well to these kinds of, requests is always going to do well. Okay, let's get to question 2, still doing algebraic expressions. So here we are not to use a calculator, so this suggests that every little step must be shown. 2.1, 2.1.1. So we've got 2 to the exponent 4x plus 1 times 9 to the exponent x times 6 to the exponent 2x minus 1, all divided by 2 to the exponent 6x times 27 to the exponent x times 3 to the exponent x. Okay, so exponential laws obviously here need to kick in. Actually, we don't really need to struggle a lot. Of course, same base with that, so we move this to the numerator. And when we do so, it's going to be 4 minus 6, which is good. But do we really want to rush it? Let's probably not do so. So this is going to be 2 to the exponent 4x plus 1 times 9 is 3 squared. So this is 3 to the 2x times here. This is basically 3, or we can say 2 times 3, all to the exponent 2x minus 1. Divided by 2 to the 6x times 27 to the x times 3 to the x. Okay, sometimes take a bit of a back seat and don't rush anything. So this is 2 to the 4x plus 1 times 3 to the 2x times, now the exponent is going to distribute to both bases. All divided by 2 to the 6. I don't know why I didn't change this. This is 3 cubed, so this is 3 to the 3x times 3 to the x, okay? Should have done this already. So this is equal to, so we can see these denominators share the same basis with the numerator, so we sort it up. So this is going to be 2 to the 4x plus 1. Then we subtract. No, we don't subtract, we add that exponent. Then we subtract 6x, okay, times 3 to the 2x plus 2x minus 1. And then we then subtract 3x and subtract x. Good. So, okay, it's going to be a bit ugly. So this is going to be 2. Now 4 plus 2, that's 6, right? Right. 6 minus 6 is gone. 1 minus 1 is gone. This is 2 to the 0 times 3. This is 4. Right? No. Yeah, 4x minus 4x, that's 0. So we end up with just minus 1. So this is basically 1 into 1 over 3. Right? So this is just a third. Nice and easy. Okay, so guys, this looks like a whole lot of work, not a big deal. So what a student can do here, can just assign any x value they like and say x perhaps is equal to 2. Just use something small, not something too big. And then put the expression into the calculator and see if this simplification will yield a third. If not, then we have made a mistake. Okay, so this is 4 into 2, then plus 1, and then we're going to say times 9 to the 2 times 6 to the 2 into 2 minus 1. All divided by 2 to the 6 into 2 times 27 to the 2 times 3 squared. I'm getting a third, so this means indeed our job is good. So this is the check. When running a check, just assign a value and then substitute, use a calculator and see if the simplified version is exactly the answer. And if it is so, then we are good. Now guys, these ones, they are boring. To check where the marks come from, it's really boring. It's really boring. Okay, let me just check this message. All right, so there's a lot, guys. So I feel like this portion right here is a mark. Of course, this is a mark. And all all of this is worth a mark, and all of this is worth a mark. Okay, there's a lot, guys. In fact, this mark, we can just mark the entire thing and say that's all the gymnastics put together, and what happens over there in the answer. Okay, it's not so easy because there's a lot of rules and there's a lot of places to consider. So 2.1.2, we are given 3 to the exponent 2021 minus 3 to the exponent 2017 divided by 60 times the cube root of 3 to the exponent 6048. Wow. Okay, let's go for it. So what are we going to do? We can see here these are on the 2000s, so we can leave them alone. But 2021, we can break it to something that shows 2017, you know, since we've got 2017 here. But let's just simplify everything first and see what we get. So this is 3 to the 2021 minus 3 to the 2017 divided by 60. Okay, let's see. This is 60 into, now this is going to be 3 to the 6048 or, okay, do I really need this? I don't need these brackets. Now remember, when you change the cube root, it's going to multiply with a third to the exponent. Nice. So we've got 3 to the 2021 minus 3 to the 2017 divided by 60 times 3 to the, let's see, 6048 divided by 3 is 2016. Okay, so now we can see that, well, we can change these to the exponents. 3 to the exponent 2016, because the smallest is the easiest to deal with the situation. But I'm not going to waste space here. We can continue on this side. So we end up with, so this is 3 to the 2016 times 3. Now to get 21, we just need, let's see, 21 minus 16, 5. This is 3 to the 5, right? Minus 3 to the 2016 times 3 to the 1, right? Exponential rules, guys. So why is this flying? So this is going to be 60 times 3 to the 2016. Okay. Nice and easy. So this is equal to, now folks, we factorize the numerator by taking out the highest common factor, which is 3 to the 2016 into 3 to the 5 minus 3 to the 1, all divided by 60 times 3 to the 2016, and of course, oops, not like that, the entire thing takes the entire thing to 1. So we end up with 3 to the 5. Yay, when 3 to the 5. This is 81 times 3. This is 243. I don't know what we're going to do here. But what I can do, because I don't want to give the impression that I used a calculator, I will say 3 to the 5 is basically 3 to the 3, which is easy, times 3 to the 2 minus 3 to the 1. Right. Perhaps let's just say 3 to the 4 times 3 to the 1. Then, okay, strategy guys, strategy. So this is over 60. So now we take 3 out. We're going to end up with 3 to the 4 all divided by 60. Now 3 goes once and goes 20 times. My goodness, so this is 81 over 20. And of course, an odd number divided by an even number, not gonna work. So this should be the answer. Okay. Nice and easy. So that was a bit of a nightmare, was it not? It was a bit of a nightmare. And Ahmad. All right. There's lots of marks here, but I think this situation right there is good. Or we can say the end result is actually good, because that's a calculation of some sort. 1 mark. And for splitting these, the entire step should be a mark. Whenever we factorize, guys, we get a mark. Now we're not going to get a mark for factorizing again, I guess, for the answer. Of course, there are lots of areas to think about. But yeah, so let's put it on the calculator and check if the answer is good. 3 to the exponent 2021 minus 3 to the exponent 2017 divided by 60 into 3 to the exponent 2016. I'm just gonna go straight for that one. It says math error. Usually with these big exponents, it doesn't give an answer. So it will say math error. So let's forget it. The calculator doesn't save us here. I know that once these exponents are huge, it just says, because remember, this is already somewhere in infinity. So we cannot get the size of infinity. That's why it says math error. It's not because it's wrong, but it's because it's already at what we could call infinity. So we don't evaluate infinity, right? Right. So that's it. Great stuff. So we have to trust the process and ensure that what we did was good enough. All right. So that's it for that question. Let's get 2.2. Now, we are also supposed to solve for x without using a calculator. We've got 2.2.1. We've got m to the exponent 8x minus 4 equal to 1. Okay? So this implies that we've got m to the exponent 8x minus 4 equal to m to the exponent 0. So our guide here is the base of m. So when we have 1, we just reverse that situation. So same bases would equate the exponents. So this implies that 8x is equal to 4, which implies that x is equal to 4 over 8. Therefore, x is a half. All right, so let's put it back. So 8 times a half is a 4, right? 4 minus 4 is 0. M to the exponent 0 is as good as 1. So this is good. So this is nice. This is nice. And using the law, nice and easy. So this is 2.2.2. We have 4 times 3 to the exponent x minus 3 to the exponent x plus 2 minus 2, sorry, plus 3 to the exponent x equals 44 over 3. Alright, so this implies we need to deal with this. So this is 4 times 3 to the x minus 3 to the x minus 3 to the minus 2 plus 3 to the x equals 44 over 3. We factorize the left hand side. 3 to the x into 4 minus 3. In fact, we can check. This is going to be 1 over 9 plus 1 equals 44 over 3. Alright, so this implies that we've got 3 to the x into, now we're going to have 9 by 4, that's 36, minus 1, that's 35, plus 9 is 44. So this is 44 over 9. Okay, if you don't know how to do fractions, folks, you are in trouble. Believe it when I tell you. So we then divide by the bracket. So this implies that 3 to the exponent x is going to be 44 over 3 multiplied by that flipped. And we cross divide. Nice and easy. So this implies that 3 to the x, of course this one leaves just a 3 there. So we're going to have 3 to the 1. Therefore x is 1. Okay, let's replace it. So this is 1, that's 12. 1 minus 2 is minus 1, so this is 1 over 9. And here we're going to have 3. So 12 plus 3, that's 15. Then we've got 15 minus 1 over 9. So what we're going to have is 9 times 15, 9 times 15, 135 minus 1 is 134 divided by 9. Icon, huh? Let me see. What did I say? This is going to be I said what? 9 times 15 minus 1 divided by 9. No, it's wrong. It's wrong, so it means I did not do my due diligence. Why do I struggle? Anyway, let's put it on the calculator, guys. There's no need to suffer here. So this is 4 into 3, right? Minus 3 into 1 minus 2 plus 3. It's 44 over 3. So my calculation went crazy. I don't know what happened, but left hand side equals the right hand side. So we can accept this guy. Of course, factorizations here is a mark. And getting here is a mark. How many marks is this? 4. Okay, yikes. Handling fractions here, I guess, is good over there, or perhaps here. It doesn't matter really. or even using the exponential laws here could be considered. All that matters is that we are doing great. Now we have, let's squeeze it here, 2.2.3. We've got x to the exponent x is equal to 2 to the exponent 2048. Again, this is infinity, so trying to put this on the calculator is going to say undefined, because we don't really evaluate infinity, do we? Now we have a problem. We never saw something like this. The base is the same as the exponent. It's like saying 2 squared, 3 cubed, like 4 to the 4, 5 to the 5, stuff like that. What are we gonna do now? Okay, 3 marks. Someone is saying this thing is simple and we don't do logs. Goodness, if we had logs I was gonna be fine. But now we don't do logs. But the problem is that even if we tried logs, this is infinity. So taking log of an infinity is going to be undefined. So it would not really work, would it? It would not work. But the good thing, if we take a log here, it would offload the exponent nicely. All right. You know, some questions like this, guys, these are higher grade questions. I mean, every now and then there's a stumbling block. Of course, skip this thing if you can't handle it. But now, the idea I'm getting is that, can I express this as the same base as well as the exponent? Because I'm getting the clue with this thinking that we could do something like this. Because if we can have, say, x to the x, okay, this is naughty, this is naughty, this is naughty. If we can have x to the x, for example, equals to 2 squared, I would suppose that for these two things to be equal, it means x must be 2. Right? That's just logic, I guess. Is it logical? I'm not too sure, but I would try that and see what happens. If it works, it works. If it doesn't, it doesn't. There's no crying here. So this means we've got x to the x, so we need to work on this one. Yikes, this is gonna be crazy. Let's just look. 2048 equals sign shift fact this thing. I get 2 to the exponent 11. Right. So sorry. What am I doing? This is base 2 to the exponent 2 to the exponent 11. Is it gonna work? Okay, it doesn't look like I'm going to win here. Okay, let's do this. This is not gonna work. I thought it was gonna affect this nicely for me, and it's not. Okay, maybe let's leave it, because we can split this into powers of base 2, and those powers we can simplify so that we can get something down here. Is it? In fact, let's just not waste our time. Let's see. This could be looked at as, say, because this is quite a big number. Let's say 2 to the exponent. Could you say 2 to the exponent 9? What is it? Does this thing divide 9? Let's see. 2048 divided by 9. Oops, it doesn't. Does it divide 10? It won't. 2048 divided by 10. Nah. Does it divide 8? It's an even number. I'm seeing that 8 there. Maybe let's try 8. 20, 48 divided by 8 is 256. So this could be 8 into 256. Okay, we're just splitting that exponent into factors. I think that could get us somewhere. So this implies that we've got 8 to the x is equal to, now honestly speaking, this is as good as 2 to the exponent 8 all to the exponent 256, right? And let's see what is 2 to the exponent 8. Wow, it works. Three-step approach, guys. Of course, try to think of things that can give you a clue. So now we got it. So this is 256 to the exponent 256. Now, I think I would say logically, I'm not too sure, guys. I would have to check there. I would say if the base and the exponent are the same and I'm getting a similar thing, I should say x must be 256. I don't know, guys. This is strange. I've never seen something like this before. And I'm not sure if I'm lying to you guys, but perhaps you guys are taught how to do this. But higher grade questions, it's something you have never seen anyway, usually. It just begs a bit from your brain that is it able to give what can just come on the fly? Because sometimes certain questions you just have to deal with them on the fly. And you just do your best and you leave it there. So I don't think there's much I can do about it. Please check with your teachers if this thing is correct like this. Because I sometimes don't even trust the memos. You can check the memo as well, but sometimes these memos from provinces are wrong. So check with your teachers or subject advisors, whatever, in your school. Some of you guys have what we call Chat GPT. Maybe this is where you would want to check it. I really don't use AI. I don't believe in it as much as people want to. For me, that's a setup for some serious disaster. Yes, it can work when used effectively, but I don't think at an educational level it should not be used. But at a functional level somewhere else, it can be good, right? So we just need to decide when and where do we use AI. But I don't think for a student doing a mathematical subject should use AI. Look, guys, don't always see an answer. You don't need to see an answer sometimes. You just do what you can and leave it at where you can stop. And that's it. Whether it's right, whether it's wrong, it doesn't matter. But what I like is that when you see the answer eventually, you will see that you actually have a fight in you, even if you didn't get the right answer. But just being brave to just walk a path you've never walked before and do your best to really move a distance in there, that's good enough, okay? You don't always have to get to the very end. There's no need. Anyway, guys, just check this one. But assuming this is correct, how many marks would we score here? It looks convincing though. I mean, the technique looks right. So I think getting here is key. Right? How many marks there? 3. And of course, if this is correct, I'm not too sure anymore. If this is correct, but it sounds convincing, guys. What do you think? Yeah, TMBs. Now the third mark for us here is perhaps using the exponential rules here. I think we can just concentrate the marks there. But even to split the exponent into factors, I think we could consider that for a mark. But I don't think it is that strong, hey? Yeah, whatever. So, yeah, sometimes, guys, these questions will dent your confidence as it is doing mine right now. You just deal with it the best way you can. And sometimes your best is not good enough. And there's nothing else you can do about it anyway. All right? As long as you tried, just settle with the fact that I gave it my best and move on. Crying about it is not going to help. Question is it fair? Is it unfair? I'm not decided on that one. All I know is that at times we need to check if a student can do things they have not seen before, just using their logic and some principles of what is already understood. So yikes, it's like that. Now folks, looking at this, what do we see? The base is a fraction, a proper fraction, and the coefficient of our power itself is an invisible 1. So this means our a is greater than 0. This means our graph is going to appear above our horizontal asymptote, right? But now when the base is like this and a is positive, it means this is a decreasing function. So we expect a decreasing function with an asymptote at -4. Okay, so obviously we will probably be asked to do the sketch. So we expect a sketch like so. So this being -4, our asymptote over there. Right, so our graph, I don't know the x-intercepts now. I'm thinking about them. Well, let's do it. If this is 0, we move 4 there. This is going to be 2 to the -x. Then this is going to be 2 squared. So this means -2x is equal to 2. Therefore, x is -2. So it's going to be stuff like this. It's pop. All right, so this is something like that. Look, guys, you don't need to really perform some serious calculations first. Just do this in your head, you'll be good. Even the y-intercept, this is 1, so it becomes 1 minus 4, which is -3, so this is good. Right? Right. So what did I say? -2x, it should be -1 up there, I think. Yeah, because this is going to be 2 squared. This is 2 to the -x, right? 2 to the -x. Yeah, it's -2, okay. Nice and easy. So we expect a sketch like that eventually. Great stuff. So let's move on. Let's just chow the questions straight up. Okay, write down the equation of the asymptote of g. So we know that y is equal to -4, easy 1 mark. 3.2, calculate the y-intercept. So we say for y-intercept, it is such that we've got g of 0. Maybe let's do it below there. G of 0 is going to be equal to 1/2 to the exponent 0 minus 4. G of 0 is basically -3. Okay, maybe let's show the steps a bit. G of 0 is minus. Yeah, I don't know what I'm doing. I'm so in a hurry for the answer. Therefore, our y-intercept is 0 and -3. Guys, I'm losing my concentration. I don't know why. Okay, we did it. How many marks? 2. Just 2. Wow. So we get the mark there. And the answer. Perhaps the answer could be marked there, but I think the ordered pair is key here because we know this is a point on the graph and we need both coordinates, irrespective of what it could be, you know. Yeah. I am thinking on the fly, so I don't know if I'm right, but it will be right anyway. So x-intercept I think this question though is crazy. Can't ask grade 11s these kinds of questions. These are questions for grade 10s, man. Can't be asking these questions unless there's something special about them. I don't see it. I think we should have just jumped to question 3.4 and incorporate those 2 marks there. 1 mark for each, 2 plus this, and make it 5 marks. I think that's how a grade 11 question should be asked. This is too much leading. Yeah, toch. Man, you can't park the car there. It's not the car park, this one. Yeah, toch. Or something else is going to happen. Alright, so it is such that 0 is equal to a half to the exponent x minus 4. This implies that 4 is going to be equal to 2 to the minus 1 times x. I'm moving quick, folks. This implies that 2 squared is going to be 2 to the minus x. Implies that 2 is equal to minus x. Therefore, x is minus 2. Therefore, the x-intercept is going to be minus 2 and 0. Nice and easy. How do we score the marks? There's a lot we did, you know. So this one I feel is good. This whole situation makes a mark here, I believe. The rest is your own problems, okay? Yeah, go cry in a corner somewhere and come back. Let's do mathematics. We are the mathematicians, are we not? Okay, we are trying, we are not. Okay, let's not say we are not. I am not. Maybe you guys are. Mna, I. And you're a mathematician. I can only wish I was. It's just in my head. It's not real. All right. So we saw that all we need is just a sketch, folks. We don't need anything drawn to scale here. Horizontal asymptote, we dash it. It must be a dashed line. Is it dashed? Or is it dashed? Iyo yonke nje into esiyicingile asinamsebenzi futhi naloo nto thina siyenza qha esifanele ukwenza. Hayi, angiyitsanzi uma inje. Ya, yona lena kuyayithatha ke goje, sekuyayithatha ke goje. Kuyithatha kakhulu ke goje. Kuyayibona ukuthi yeta lethu lekiyifunako. Ya, akunathaba lokuthi le scale salaka sikhaba njani. Siyakhaba cha. Kesiboniye mina ukuthi sikhabile. Okade okujeda laka. Right. This is F. Nice and easy. Oh, it's G. Hey. Let's write the right one. Okay, guys, is there anything? Of course, we needed to clearly show the intercepts as well as the asymptote. All done. So we get a mark for the shape of the graph, any one of the intercepts, and the asymptote. Kitrima kantwena re qetile 3.5. It says calculate the average gradient between the intercepts. Okay, the x and the y intercepts. Okay, so we know that the m average is going to be, at this point we can just decide, because we didn't call these ones anything, I suppose we can now write the generic formula. All right, so minus like so. This second y is not minus into minus 3 divided by minus 1 minus 0. Is it 0 or is it 0? So this is going to be 3 divided by minus 1, which is minus 3. So it's good, it's a negative gradient. I can accept the answer. It's just going to be a matter of my substitutions. Is it? Yikes, because this is the average gradient between, or basically we can say we want the gradient of the second through those points, through the x and the y intercepts. How many marks there? 2. So substitution, answer. All right, 3.6. We are asked to write down the equation of k if it is given that k of x is g of x plus 4, meaning we are moving the graph of g 4 units upward. All right, question is write down. So k of x is going to be, this one will not change because it's just a horizontal shift, is a half to the exponent x. Now this was minus 4 plus 4, it becomes 0. Remember, when the question says write down, answer only. Don't show us the method. All you do is just add 4 there. Not here, but there. Now that becomes 0. Done. Okay. Now we go on and say 3.7. If it is further given that h of x is equal to 2 to the exponent x plus 3 minus 4, explain in words how graph G must be transformed to obtain the graph of h. Interesting. BSF 8. Well, we can see here we manipulated this graph horizontally. Okay, we manipulated that graph horizontally. Now we need to create a nice template that we are going to explain. So let's just reverse this whole thing and make it look like the other one. We know that g of x was basically 2 to the minus x minus 4. So what happened now? We can say, well, what happened now here is that there's 2 shifts that took place here. This is going to tell us that we must have moved to get to something else. Let's see. Let's say now to transform this to h, we must have set 2 to the exponent minus. Now we multiply the x by a negative. That's a vertical. No, that's a horizontal translation. When we multiply the x value by negative. Right. But then, what do we do there? Okay, let me think about it first. Here's what I'm thinking. We first shift this thing horizontally to the right. Let's say this is x minus 3. Okay, just leaving that x there. But now, if we shift it to the left, then we multiply the x by negative. You get it? So this is what it looks like, because when we sort this out, it's going to be 2 to the x plus 3 minus 4. So first of all, we need to describe this. What is this? That's a horizontal reflection, or the reflection about the y-axis. Then we translate this to the right by 3 units. Let's go up. Hey, what? Yeah, I would say that. So that's a lot to say, but we say it anyway. So this one is a bit cumbersome to go about it, but yeah. because here it's only the answer that's required. We can say H, no, let's just write H is the graph of G horizontally, or we can say about y-axis, horizontally reflected and then translated. Now we're using the nice words. Translated 3 units to the right. Okay, I don't have the right to do that, so to the right. Nice. So the graph of H is the graph of G horizontally reflected. Now horizontal reflection, or can say reflection about the y-axis. Good. And then translated 3 units to the right. Great. That's for me a good idea. So this should be 2 marks because there's 2 things that happened here. This and that. But I suppose since we did all of this in one spot, is there something else? Yeah, man. I'm trying to think. Let's just draw this graph, let's zober it so that we can see if it indeed speaks the same sense that we are thinking. It's easy to think you are right when you're wrong. Let's just draw the graph, Asymptote is the same. So let us see. What is the sting? X-intercept, we take 4 to the other side, it's 2 squared, so we're going to end up with 2 is equal to x plus 3, transpose x is minus 1, okay? Then the y-intercept, this is 2 cubed, which is 8 minus 4, which is going to be 4. Oh, this is an increasing function, by the way. So this one is going to do stuff like so. Yes. This is h. So it will cut at 4 and minus 1. Now, this indeed looks like a horizontal reflection of this graph because it flips over like so, like that. And then we know and understand that it would then be shifted to the right for us to really get to where we see ourselves there. Yikes. I would believe it. I would believe it. But the other thing is it shifted to the right or to the left. That's where I am not so sure. That is where I am not so sure. Because if I'm saying to the right, mind you, when we shift this, when we flip this like that, this point goes there, this point will get here somewhere. Can you see? Now to hit that y-intercept, we would have to shift it to the left rather. So it means I did some crime here. What I was supposed to do here was to do this. The x must be minus multiplied by negative, so square brackets. So we would have x plus 3. Yeah. So that would constitute the horizontal reflection. This would be a shift to the left, but when we simplify all of this business, it gets us where we are. Because I'm thinking if we do this to this graph, right? Let me just show you what I'm thinking about. Now we want to flip this graph, right? When we flip it, remember this is like that, then when we flip it, it goes on to something like so. Right? And then we move it back. So do you see the y-intercept must not change, but the x-intercept changes from -2 to +2. Right? Right, so this is what we would have. But then do you see the y-intercept is -3. So for us to get a 4 there, we need to shift this graph again to the left. Like so. Right. What is he shifted on? Yeah. Stuff like that, brothers. Stuff like that. Do you see now? It means we shift it to the left 3 units, not to the right. Wow, that was a naughty question. It was a naughty, but nice, you see. It's nice, but it's chilly. And then translated 3 units to the left. Great. So the translation is to the left. Wow. Okay, I guess that is good for 2 marks because it is not so easy to tell. Not so easy to tell. Okay, guys, yeah. Did you have Okay, that one was a higher grade question. It's not so easy to figure out, but I'm sure you can see the trouble we had to go through to get it right. Ah, see, Kabil. Yeban. Not that one. That one is standard grade. This is higher grade. Okay. Jian. Next one. Hyperbola. Okay, how many marks was this? 14 marks. Okay, guys. So you can see that there's always a question in each question that is a bit naughty. But naughty as it is, we know what to do. We just have to be ready. Okay, we're given the function f is equal to a over x plus p plus 1. All right. So now here we have a problem because we don't see the graph, what it looks like, but all we know is that the horizontal asymptote is at 1. We don't know the status of A, we don't know the status of P. But what else are we given? That it has an axis of symmetry with this equation. So we know that literally this is saying y is equal to minus x plus 3. I'm just writing it in a way that I can understand that this is 1 with the negative gradient. Okay, all right, okay. So we have something. So what do we know, guys? Okay, it says write down the range. So this is cool because the range of this graph is only limited at the horizontal asymptote. So we can just start with that. 4.1, we know that the range is equal to a set of y values such that y is an element of all real numbers except that y should not be equal to 1. Okay, so that's the limit there. Nice and easy. So one can write interval notation or inequalities. This one is easy to do, so I think the mark here is on the limit. Alright, so 4.2. We need to determine the equation of the vertical asymptote. Just 2 marks. Okay, alright, okay. So, well, we know that the center of this graph is such that 1 is equal to minus x plus 3, isn't it? This is the y coordinate at that center. So we know that that center is where this very same line passes. Where this line passes through as well. So we just solve for x here, which implies that our x is going to be 2. Right. Now, is that the vertical asymptote? The answer is exactly. That is true. So, determine the equation of the vertical asymptote. So let's say beta. But we know that this goes with the center or the point of intersection of the asymptotes or the point of intersection of the axis of symmetry. We get the 1 from there. Alright, so this is easy, 2 marks, guys. Substitution and the answer, nice and easy. 4.3 says, if f of 0 is 2, calculate the value of a. Now we are told a point, so we know that, well, f of x is a over x. Now this goes into the equation as negative plus 1. We need to write that. Now given this point that x is 0 and y is 2, it is such that 2 is equal to a over 0 minus 2. So this tells us this is the y-intercept, by the way. So this implies, we transpose there, we get 1 over 1 is equal to a over minus 2. Cross multiply. Can say therefore our a is minus 2. Okay, alright, okay. So easy, 2 marks again here. Just substituting the point and getting the value of a is what matters here. But I do feel though, to know that the sign needs to be negative here is also of some consideration for a mark. 4.4. We need to calculate the x-intercept. So for x-intercept, okay, in fact, let's first write the equation nicely. We can say, well, f of x is going to be minus 2 divided by x minus 2 plus 1. And then we can say for x-intercept, which is such that 0 is minus 2 over x minus 2 plus 1. This implies that minus 1 over 1 is equal to minus 2 over x minus 2. This implies cross multiply. We get minus x plus 2 is equal to minus 2. So therefore x is going to be 4. Therefore the x-intercept is 4 and 0. Answer. Great. This is 3 marks. Okay, substituting there, getting this, nice. In fact, the mark on the substitution is on 0, I suppose. What else? Perhaps writing the equation in full. Oh, that's weak. Okay, that's strong. That's strong, I suppose. I don't understand why 3 marks. I don't understand why. Anyway, guys, whether I understand or I don't, nobody cares. 4.5, we can put down the sketch. Now, we have an asymptote at 2, a vertical asymptote. I can say this is 2 over here. And we have another one at 1. I can say this is 1 over here. It really doesn't matter where the 1 is or the 2 is. So this is the x. That's the y. That's the origin. Okay. Now, we know that when this is the case, A is negative, so the graph is in the 2nd quadrant and 4th quadrants. Now let's see. This one goes stuff like so. And then we know that this here is 4. Okay. Okay. Nice and easy. So what did we get there? It was 2. Yeah, the y-intercept we were given anyway that it's 0 and 2, so I can write a 2 there. Is finished. Now we dash our asymptotes. Now, what do we have there? This is 2. That is 1. Okay. All right. Okay. The graph is done, guys. So 4.6 says write down the values of x for which f of x is less than or equal to 0. So this is this segment right here. Equal to 0 and less than 0 over there. Alright, so we will write here x must be less than or equal to 4 but greater than 0. No, 2. What am I saying? Because we know that 2 is not allowed. And this side is positive. So we are getting 2 marks here for those 2. 4.7. Now we're told also the straight line y equals minus 2x plus 5 passes through the point of intersection of the asymptotes, which is this point right here. of the asymptotes and intersects f at p is 1 and 3. So let's just draw this sketch nicely. Just to get the idea. Okay, let's not dash it because we're suggesting something else now. And we know that this should be the point where 1 is to 3. Okay, yes, it's not to scale, but that's what we're thinking. But please don't write these things on the graph that should be presented for the answer. Okay, but now I don't want to draw the graph multiple times, so just work with this. Now, where is the x-intercept? We see that this is going to be minus 5 divided by minus 2. That's just 2,5. So that should be okay right there. This is 5 over 2. Again, we don't want to see this in the graph that is presented, but we're going to use it now. Great. Intersects this and q. So we know that this is q. So it means this one right here should be q. And that's what we want. Write down the coordinates. Again, it just says write down the coordinates of q. How do we do so? Well, what do you guys think? What do you guys think? What is this graph? What is this graph? This is an axis of symmetry. Is it? I want to believe so. But it can't be the axis of symmetry. No, it's not the axis of symmetry. It is not the axis of symmetry. Because the problem with the axis of symmetry here is that no, it's not. I'm lying. Remember, the axis of symmetry must have the gradient of minus 1 instead. Right. Now, let's have a look here. We were given the axis of symmetry for this graph that has the negative gradient. So the axis of symmetry is doing this. So what is cooking? What is cooking? Sorry guys. So the axis of symmetry was what? Let's just do something else. I need something else. So the axis of symmetry is also doing its own things, né? Because if this is minus 3, it means x is going to be 3. So probably here, if this is 4, 2,5, 3 should be there. Yeah, this is the axis of symmetry. This is the axis of symmetry. Ne? Yeah. So it will pass at 3. This graph is becoming busy now. Okay, so this line you can see it's not exactly the axis of symmetry, right? Right. But the gradient is minus 2. Okay, But write down the coordinates of Q. You know, guys, I would like to believe, though, that if you look at this graph, it looks like this is going to be 3 and minus 1, you know. I want to believe, so that's going to be 3 and minus 1, meaning it's an inverse of that. But the question is why? Why is it an inverse? Why is it an inverse? Is there any sense to this? Yo, guys, we'll be told time up now. I think that was a 2-hour paper, isn't it? Yeah, so this would be over. Yo. But of course, you would have answered most of these questions, right? I'm trying to explain, so it's like this. So let's not drag this too long. I'm gonna say Q is 3 and minus 1. I don't know why. I don't know why it is so, but I'm trying to think now, why is it so? Why? All right. Yeah, but there's something about this, you know. There is something about this. But then let's just do the long job here, which is boring. So we know that minus 2x plus 5 must be equal to, what was this? It's minus 2 over x minus 2 plus 1. Multiply throughout by the common denominator, so we get minus 2x into x minus 2 plus 5 into x minus 2 equals minus 2 plus x minus 2. Right, we fold this out, we get minus 2x squared plus 4x plus 5x minus 10 equals x minus 4. We sort this out, we get minus 2x squared. We've got 9x minus x is going to be minus 8x. 10 plus 4, that's going to be minus 6 equal to 0. We divide by 2x squared minus 4x, no, plus 4x plus 3 is equal to 0. Then we get x plus 1 plus 3. Therefore, x is equal to minus 3, or x is equal to minus 1. All right. This is just not working out. It's just not working out. Because I'm getting answers that are not the ones. Or did I make a mistake? Because you see, the problem is that these are supposed to be positive, it seems. So it means I have made a mistake here in my calculations. It means I've made a mistake. This is minus 2x times x minus 2, right? Which is going to give me minus 2x squared plus 4x. This is plus 5 times x minus 2. This is 5x minus 10. So this is good. Then I come here. It's just going to be minus 2. Then plus 1. So this is 1 into this. So it's just going to be this. So this is x minus 4. I transpose this here. minus 10 plus 4, that's minus 6. And then I've got 4x, 5x, that's like 9. 9 minus what is 8. This is plus 8. God, I made a mistake here. So this was supposed to be plus 8. Okay, that's where the sign went missing. Because then the sign here becomes negative now. And this becomes negative. And ibese yahlangana ke ngoku ibese yadibana. So this is 3 and 1. And can you see indeed that is 3? Then we take this 3 and substitute into the linear one. So this is minus 6 plus 1, which is minus 1 indeed. I don't know why it works, but it worked. Again, you could have guessed it if you didn't know how to do it, and you just get your 2 marks here for the 2. But it looks like that is the case. But now I'm trying to think why. I am trying to think why. Why? What makes this work? Sort of like an inverse of some sort. Why? I get say visual, lenna ke markets. Hore. Hobaneng e sebetsa like an inverse. I don't know, guys, but it is what it is. It is what it is. So the answer is done. And we score our nice 15 marks. Sometimes you're not always gonna know everything, but you can think with me now, if you can, and let me know why does it work like an inverse. Why? Because I'm thinking about the axis of symmetry that passes over there. It's going to be y equals, the positive one is going to be just x minus 2 plus 1, which is going to be x minus 1. Right. But now when you take this gradient, minus 2 times minus 1 is basically 2. So we wouldn't say the 2 lines are perpendicular, so that we can think of it that way. But all I know is that the distance from the center to the graph and from the center to the graph is the same. Right? So this is more like reflecting this point along a line perpendicular to this through this point to come here. So we can imagine something like that. So if we reflect this by a line that is perpendicular to this one, it means it would become an inverse in a way. I guess that's the best explanation I can give. Whether it's right or wrong, I don't care. Maybe you do, but I don't have the time, because time is money. Money is very scarce. Economy is made to crash, so that countries that are trying to rise up to the occasion can just remain right at the bottom. The graphs of h of x equals ax squared plus bx plus c, the standard quadratic, and p of x equals 8 minus 2x are sketched below. So the gradient is negative for the straight line, Nice and easy. And we know that at E, it's going to be 0 and 8 because the constant is there. X is 0. If we work out D, we make Y 0. So basically, it's going to be 8 divided by 2, which is 4. So this is 4 and 0. This one is easy. Now the x-intercepts of H are given. And the y-intercept of H is given. So there it is. M is the turning point of H. Great. So this is X is to Y. D and E are the x and the y intercepts of P, respectively. We already saw that. Okay, so what do we see? It's a grumpy face parabola. So it means our A here is less than 0. That we know. Okay. Folks, there's no need to dilly-dally here. How do we find the x-coordinate there? Easy. It's the average of these two. So this plus that is going to be minus 2 divided by 2. That's minus 1. Now the the y coordinate is what we don't have. Okay. So that's about what we can do. Otherwise, nothing else. Great. So let's go for it. 5.1. It says write down the coordinates of D. So we already worked them out. So we just write D is 4 and 0. Get 1 mark. 5.2 show that A is minus 2. We saw that we needed a negative number. B is minus 4 again. We needed a negative number, seeing that this would be negative to get us here. And of course, C is C. This one is crazy because it's already given, guys. There. Why are you asking about it? You're not careful, Nina. Don't do it. Don't do it. You already gave us this one, so it shouldn't matter. These ones definitely do matter. Okay, guys. Now we have a problem. You understand. You understand. We got a problem. Our problem is we don't know what to do. You hear? Yeah, but here we don't really have a big problem. We've got 2 intercepts and a point, so we are done. So we know that we're going to write this in the intercept form. So we can say H of x is a into x minus the first root to x minus the second root. So this implies that h of x is a into x minus 3 is going to be plus 3 to x minus 1. We take the point, which is the y-intercept, which is 0 and 6, will be such that 6 is equal to a into 0 plus 3 into 0 minus 1. We've got 6 is equal to 3a. Sorry, minus 3a because of this negative. Therefore, a is minus 2 indeed. Okay, good. We can say then, it's not f, but h of x is minus 2 into x plus 3 into x minus 1. Expand this. This implies that h of x is minus 2 into x squared. Minus x plus 3x is going to be plus 2x minus 3. You can say therefore h of x is going to be minus 2x squared minus 4x plus 6. Therefore, here the b, we got the a value, so I think we needed the b. Okay, let's list them all. A is minus 2, b is minus 4, and c is 6. Okay, that's good. So what is the story? This thing is good. Substituting a point is good. getting us the nice equation there. 3 marks. How many marks there? 4. Okay. So this one and that one, because this one was given. Alright, so 5.3. Calculate the coordinates of M, the turning point. Very easy. Well, we can see that x at M is going to be minus 3 plus 1 over 2. It's the average, which implies that x at M is going to be minus 1. We can say then y at M is going to be h of minus 1, which is going to be minus 2 into minus 1 squared minus 4 into minus 1 plus 6, which is equal to, this is minus 2 plus 4, that's 2, plus 6, that's 8. Okay, so therefore M is the point minus 1 and 8. Question was clear, calculate, so we needed to show a calculation. Nothing else. Nothing else. Wow. 2 marks for this too. Goodness. Angazi nami ngizothi ikuphi ke le mark. Ngoba ke is everywhere, so I guess we get the marks for the answer, but we need to show how we got to it. Because we were asked nicely to calculate. So 5.4. We write down the range of h, so we know that range is going to be equal to y values such that y is less than or equal to 8. Done. So that's a very easy 1 mark there. 5.5. Determine the values of x for which h of x times p of x is less than 0. So we are saying y values of h times y values of p. So that this is negative. So obviously the key areas are these. So technically we need to consider the 2 areas because 0 is not included. So we need to check when this product is 0. Now, more. Yes. So this is the areas to check. So literally after 4, this is negative, the product is greater than 0. So this interval is out. Now we come back in here. It doesn't matter really, guys. We can read the graph from left to right. It always works that way because we can see that beyond this minus 3, these y values are negative, those y values are positive. So negative times positive is negative. So we understand that this is good. And zeros are not included. So these are out. We cannot include these ones. All right, so we come in on the inside. What do we see? Positive y values, not a good interval all the way until here. Positive y values, positive, don't. So this interval is out. And then we don't like this. So these ones are negative, these ones are positive. So this is a good interval until we get to the limit. So literally we've got those 2 intervals. So we can say here x must be less than minus 3 or x must be less than 4 greater than 1. Nice and easy. 3 marks there, this and that, like that. Okay, 5.6. We are told to take if h of x is equal to k. Now this is a horizontal line. Right. Now determine the value or values of k for which the roots. Okay. If h of x is equal to k, what am I saying? Goodness, dear Buddha. Dear Buddha. H is the height, is our parabola, and k is any straight line. Actually, I meant to say this k here. This k, can say y is equal to k is a horizontal line. Nice. Now, this means we can just draw any horizontal line. How did you disappear? This horizontal line can be anywhere, but we're saying the roots must be non-real, meaning no intersection with h. Right, so if we draw this horizontal line over here, perhaps, say, okay, let's just put it on the Cartesian plane nicely. So we see that when we draw this line over there, and then take this line perhaps at the turning point, the critical areas, and then we copy it again, and then take it above there. So these are the possible lines, y equals k. Okay, then k is at the y-intercept, the y value or the maximum value of the parabola, or when it is above or when it is below. So we'll see that essentially there's 2 points of intersection here. So that's not good. There's 1 point of intersection there, not good. No point of intersection, that's good. So we can say here 5.6.1, we can say k must be greater than 8, because we saw that the maximum value at m was 8. Okay, easy one, mark. 5.6.2, it says they have roots that have the same sign. Holy cannoli. So now we need to come back here and say, okay, there's another point that we need to consider now. Paste. We need to consider the y-intercept here, right? Right, and then we copy this and add another. We also need in between here. Okay, I don't know where my red went. So can you see this is still y equals k, y equals k. Now we see that these roots have unequal signs, negative and positive. Not good. And when we come up here, this is 0. There's only one root. So 0 is nothing, honestly. So we cannot say 0 is positive or negative. So this is not good. But if we look here, this is negative, this is negative. See, the roots have the same sign, meaning there's 2 of them, because we can't have. And again, here, we've got 2 roots that are equal, and they are of the same sign. But when you consider these 2 graphs, that's just 1 root. So we're not going to focus on that. So this means the value of k must range between those 2 lines. So we can say, well, k must be less than 8, but greater than the y value there, which is 6. Nice. So that makes it work. Okay. So 5.7. Well, the marks are already telling that we're going to be in trouble. So that should be a higher grade question. let's see. It says calculate how the graph of P must be translated so that it becomes the tangent to the graph of what. Okay, now we understand and could pretty much see that if we draw this graph of P nicely and we take it, we cannot translate it upwards. Hey, supapa wena man. Sonhlanyisa wena. We cannot translate this upward, right? Because it's not going to touch. But for it to be a tangent, it has to come down like that. Then it becomes a tangent at this particular point over there. Okay. So, what do we need? We just need the corresponding y value there. If we can find out what that corresponding y value is, we will know that from its y-intercept of 8, right? From its y-intercept of 8, we'll just take that distance and say by how much must we go down. We'll just say 8 minus this value here. It's going to be the distance that we need. Okay, so this is not too difficult, but we just have to kind of deal with issues. Of course, grade 12, this is a nice question because we can use differential calculus to find the x value and the corresponding y value and then take the difference. Then we are done. But for grade 11, we are in trouble. So we need to first use our nature of roots here, without which we would not win. Okay? Yeah. We need to use nature of roots here so that we can win. So first, we would say, okay, all right, okay. We know that we need to take some, let's say here, if we write our P of x is minus 2x plus 8, then we need to cancel, or should we say we can add or cancel, but now we know we want to cancel some value b. Okay, let's not use b, but some value m. Now we need to find out what is that value of m. If we find the value of m, we'd know that we're taking it down. So that's how we're going to say this must be translated down. Okay, what is this? Oh, these are the marking guidelines. So we can check if our answer above is good. So, you know that question that we were not so sure. We will confirm. Now calculate how graph P must be translated so that it becomes a tangent to graph of H. Nice. So first of all, we will just say, well, this already tells us that perhaps, or technically, did we find the equation? Yeah, we did. This technically says we want to say H of x is going to be equal to P of x minus m. They must have equal roots. So this implies I'd like to start nicely, man. Not like this. Not like this. We can say now at point of tangency, which I would like to call the pot. Remember, don't start saying pot when we don't know what that is. We understand that h of x is equal to p of x minus m. You can even say plus m if you will. It's not a big deal. This implies that we have minus 2x squared minus 4x plus 6, right? Is equal to minus 2x plus 8 minus m. We write this in standard format, minus 2x, we transpose, we get minus 2x here, minus 2 plus m equal to 0. Now we can say for equal roots, we know that delta must be equal to 0. This implies that b squared minus 4ac is equal to 0, which implies that minus 2 squared minus 4 into minus 2 into minus 2 plus m must be equal to 0. This implies that 4 plus 8, no, this is 8 times this is minus 16. 4 times minus 16. So this is 8. This is 8 times this is going to be plus 8m equal to 0. You too far. Hadamela mona. So this then confirms for us that 8m is going to be, this is minus 14, minus 12. So this becomes 12. Therefore, m should be 12 over 8 is 6 over 4. No. 6 over 4, which is 3 over 2. Yeah. 4 goes to 12 3 times, to 8 2 times. So we can say, therefore, the graph, therefore, P must be translated by 1,5 units down to become 800 to h. Wow, lots of work. Okay, so that is essentially how this works out. Wrong or right, I don't care at this point, but yeah, it works like this. All right, guys, so yeah, that's a lot. Of course, this whole business is good. This is good, and that is good. The fact that we said down because we need to subtract is very good. 3 marks, getting this thing 4 and perhaps 5, I suppose, I believe. But the other thing, because I think doing that is as good as that, so I suppose the substitutions into the discriminant and equating that to 0 is much more powerful. And perhaps not here because a student knows already what to do, but here, especially for this, especially for that. All right, guys, so this is a very nice higher grade question that many of you should already be very familiar with. And that's the end, guys, for a total of 100 marks. Okay, so we've got the marking guidelines here nicely, so we can check that question. To remember that question that was naughty, this one, 2.2.3. Siyabangena. Sometimes I'll go sure at school, but I don't trust the memo, you know. The teachers must confirm for us if this is acceptable. But of course, if we thought about it and it's there in the memo, why not? Why not? Yeah, boss. Okay, all right, okay, guys. So let's check even the last one because, wow, I'm not so convinced, but not necessarily because I think it's wrong, but because, see that point, we got it. Why the switch? I cannot tell you. Switch or no switch, we are fine. Switch or no switch, we are fine. Yes. So that's about it. But here they decided to just add K, but it doesn't really matter as long as one understands what is needed. That's good. If one understands what is needed, it's good enough. Okay, guys, so we are right where we need to be. Okay, so I hope you enjoyed the review. You have the memo here. You can enjoy checking if everything we've done is right, but I believe it is. So don't attach too much though to memos, because just focus on generating the memo yourself, because that way you will not even need to be convinced by any memo that is to come in the future to see how well you did in the exam, even before you get to see your script. All right, so folks, there's no excuses. You know how to do the work. You know how to check yourself during the exam to ensure that the marks you are scoring are exactly in the bag. You can already work out your percentage. You can work out whether you scored a distinction in that test or not. Of course, when the paper comes, some mistakes you will come to know them when you see the paper, because you don't remember what you did. It happens sometimes. You know, things can change depending on whatever is the circumstance surrounding the change. What matters, guys, is to be at your best, to study, and to win. I hope you enjoyed the video, and good luck with your mid-year exams. I'll see you when God allows me to see you again. Bye-bye.